Okay, guys, so let's start. So yesterday there was some confusion about the sequence number. Okay, so let's consider this is one of the client here. Okay, so and this is a client A and this is about client B. Okay, so we are doing the sequence number. Okay, will take 2 or 3 minutes, not more than that. Now, so just consider first of all, first this is about the three-way handshake process. This is a three-way handshake process is going on, and this is finished now. Just consider it. This is done here, and now this is also done here. Okay. So in the first packet, okay, if I'm talking about the three-way handshake process. So in the three-way handshake process, the first sequence number is always about the random number. So if I'm talking about here, the sequence number, let's consider I'm using 100, random number, just consider it. So the 100 there. So this is about the sync packet. So it means when your reply will come back, which is about your send plus add there. So on that time, two things will be there. One is about the sequence number. This is about the sync number. Means I'm talking about the sync here. Okay, that is considered about 200, and then acknowledgement will be about +1, which is about your 100 plus 1 and equals to about 101. This one which we are using here, if I'm talking about this one here, 1 second, this specific one, okay, this is known as your phantom bit, phantom byte actually. This is known as phantom byte. Phantom byte. Now, after that, from here, now the sequence number, after that, once the acknowledgement will goes out, so the sequence number, this is about sequence, that will be 101. And if I'm talking about acknowledgement, the acknowledgement will be about 201. Okay, which is about 200 plus 1. Okay, and this time, the acknowledgement number will be 201. This is the thing. Okay, now next thing is this is about my now the connection established here. If I'm talking about connection, so the connection established now. Let's consider it. The connection is established. Connection got established, and this is also established. Okay, this is established. Now, so after that, now data transfer begin. From here, data transfer start here. Okay, begin here from. Now, when your data, this one, the data transfer start. So the first thing, now consider it, we are sending the first data. This is my data here now. So when we are sending the data, this time, just consider the data is about the data length. Okay, the data length here, or not data length, you can say segment length is about 10 bytes. That is about 10 bytes. So this is a normal 10 byte, and this is also known as data in flight, okay, or bytes in flight actually. This is also known as bytes in flight. Just now. When we are sending this data, now the sequence number, okay, will be about this same number, guys, which is about 101. Here I was confused yesterday. This one, 101. I'm talking about this same sequence number. This one. Okay, this is current sequence number, and after that, here we have to mention now what is next sequence number. The next sequence number will be about your 101 plus this 10 there, which is about your byte, and which will become your 111. Got it? Now, this is my data. Once this data will reach at the destination side, after that, this destination send, okay, will send the acknowledgement. This is about, black color is about acknowledgement here. So this is about now, this is my acknowledgement. Okay, so what will be the acknowledgement? Acknowledgement will be your 101, which is your data, plus this 110. This is what? This is 110. 110, which equals to about 111. And this means ki, hey, now I'm expecting this sequence number for you. And it will mention here, I am now expecting the sequence number 111. See, last time, this was not the sequence number. This was just mentioned ki next sequence number will be this one only. And now I'm saying ki, okay, up to 110 I have received, and now I'm expecting you like 111 sequence number there. So this time, again, the next sequence number, when again it will send the data. This is the data of like this color here. I'll consider data. This is the data, and in this data, the sequence number is about 111. 111 plus the segment length is about, consider 5 bytes. Let's consider it 5 bytes. When we are sending the 5 bytes, then here it will mention the next sequence number will be 111 plus 5, which equals to 116. This is done. After that, again, your acknowledgement will be there. This is what? This is the acknowledgement number. So when this acknowledgement number is there, so in this acknowledgement number, it will mention here the acknowledgement is about 116. That is about, again, 111 plus what are the data? 5 bytes, which equals to 116. And it will mention here ki I'm now. It means ki I'm expecting 116, means I'm expecting next sequence number as a 116. Got it? This is, I'm expecting this thing. It means actually. So if it's already mentioned here last time, yes, next sequence number will be 116. So when we will send the next packet here, next, this is the data again. So then now it will be what? Then again, the sequence number will be what? 116. The sequence number will be now 116. 116 here, the byte, the data is considered now 10 bytes here, or maybe 100 bytes. Just consider. So now next sequence number will be 116 plus about 100 is equals to 216. This is next one. Again, it will send ki, okay, this is okay, that's great. So now this one here now, and this acknowledgement is about what? If I'm talking about acknowledgement here, what is acknowledgement? Again, 116 plus about 100, which is about equals to your 216. And next time, again, the sequence number will be 216. So again, next time, the sequence number will be, if I'm talking about sequence number, so that will be 216. And now next, again here it will, we have to mention here next sequence number, that will be depends on 216 plus like your flight or bytes in the flight, or you can say about segment length. So like this says, in this way your sequence number will works actually. Yes, yesterday I was confused here actually. Okay, so 3 things will be remain same here. Okay, yesterday I was actually confused here only. I was considering this one as a sequence number, but actually this is next sequence number. So next sequence number is obviously I have to mention in the next packet sequence number what? 1111. Okay, and this guy is saying ki, okay, up to 110 I have received, and now send me to this 111. Got it? Okay. Yes, guys. Any doubt? Any questions up to now? Anyone? Yes, guys. Any doubt? Any questions? What about yes, this Vinay? What like is that doubt or like clear?
So for every acknowledgement, sequence number will be incremented by 1, sir.
1 second. Can you speak loud? 1 second. Yes, tell me.
For every sequence number of acknowledgement, it will be incremented by 1.
Not by one. Depends on your bytes. Segment
Okay.
bytes.
Okay.
Okay. What is your segment length? In acknowledgement, in three-way handshake process, it will be increased by 1 only. Can you see here? It's increased by 1. This was increased by 1. And if I'm talking about this one, this is also this part. If you can see here, this is also increased by 1 here. Can you see this one? This one and this one. If I'm talking about these two ones, this is known as guys phantom byte, because this is data is there is a no data transfer, because this is not the data about data. This is about what? This is about just negotiation. So on that time, this is type of dummy data, and which is about known as your phantom byte. We are using always one phantom byte. So in exam, also not in exam, sorry, in interviews they can ask, do you know or can you explain what is the phantom byte? So phantom byte is about always.
So while initial negotiation, the phantom byte will come into picture, and then instead of phantom byte, actual length of the data will be added to the sequence number and then given as the next sequence number or the expected sequence
Exactly.
number.
Correct.
Right.
Correct. Because obviously next time when sequence number will be there, we need some data, and what is we have to add? Then we have to add data over there.
Data, length of the data that is transmitted in that particular transaction.
Exactly. Yes, Debashish, this phantom number is always about 1. Okay. This is fixed actually. Okay. This is always 1. Okay. Yes, guys, any other doubts? Any questions? Anyone else? Okay. Now, this is one more extra thing I just want to add here. Don't be confused into this one. Okay, if you want to go through that, you can, but this is interview perspective, not important because they will not ask you this thing. But yes, when I was doing all these things, so I was like going through this thing also. See, right now, if I'm talking about here, I'm talking about these two things here. Actually, now yesterday I was trying to add this thing, and because of this thing also, I was just got confused. This one here. These two packets, first packet and first segment. Yes, and one more thing here, guys. This is about my segment number 1. See, this is about when sending three-way handshake process and all on. So this is about segment number 1, segment number 2, and this is segment number 3. This is about your, just consider it as a segment number 1 as a 1. Next is about, this is 1. This is segment number 1. I'll mention here only 1 second. And this is segment number 2. This one, 5 bytes. Okay. This is segment number 3 now. Okay. And this is after that segment number 4 here. Okay. Because after that, what will be there? From here, your acknowledgement will be there. Okay. And that depends. And what is the acknowledgement number from here? Act will be about 216 plus again the same segment length. Okay, this is about the segment. This is. So now if I'm talking about first segment, okay, we have one more concept into that, that is about data allocation there. How many bytes do we have? We have 10 bytes into that. Okay, so let's consider this is that 10 bytes of data here. Okay, just consider it. not that much important, but yes, if you will have the knowledge of this thing, it will be a plus point for you. The first, this is the second, and now 2, then 3, then 4, then 5, then 6, 7, 8, and that is okay. So now see, if I'm talking about bits of byte, how many bytes do we have, guys? Can you see how many bytes do we have? I have mentioned here 10 bytes. I have mentioned here now 10 bytes. Okay. So now this is byte number 1, byte number, this is byte number 1, byte number 2, sorry, byte number 2, byte number 3, byte number 4, byte number 5, byte number 6, byte number 7, byte number 8, byte number 9, and byte number 10. 10 bytes we have. Okay. So what about its sequencing number? How will it start actually? So guys, what is my sequence number in the segment 1? It's always 101. So the first sequence number will start here with 101. This is the first byte, this sequence number. The next is about 102, next is about 103, next is about 104, next is about 105, 105, 106, 107, 108, and after that, this is about 109, and this is about 1110. So see, guys, simply very just now, tell me one thing, guys. What is my last byte here? What is the last segment here? 1 and 10 here. Now, from now this packet, if I'm talking about this one here, let me add. Okay, keep it here only. Now, see guys, into this one, 110, this is my last byte or not? Okay, so see, what is the sequence number I'm sending? 101. What is the next sequence number I'm sending here? Okay, my next sequence number will be 111. So obviously, after that, what will be my next sequence number, guys? If we will start with this one, what will be the next sequence number? That will be obviously 111. If this is 110. So this is the reason that now on this side, this client or this PC is getting the packet here up to where? Up to 110, and now I'm sending the acknowledgement key. Yes, up to 110 I have received, and now I'm looking for 111 here. I'm looking for what? 111, and in the next sequence number, what we are sending? We are sending the 111. Clear or not? So when the next sequence number will be there, okay, so what will be the sequence number? The sequence number we are sending what? We are sending 111. Got it? So this is this concept with this one. Clear? I hope this is clear now. So this is the concept of your sequence number, and this is the concept of your sequence number allocations. So in the next segment, then the first sequence number will be about means key is saying yes, I'm expecting now 111 because up to 110 I have received. So and in the next segment we are sending what? About 101. Oh, sorry, 111 actually. Clear or not? Okay. So into next one again, we are sending what? We are sending how many bytes? We are sending the 5 bytes again. Okay. So this is the 1, this is the 2, 3, 4, 5 is done. So now what is my sequence number? Now next is about sequence number will be about 111. So now this is C here. This is about what? This is about 111. Then about 112. Then about 113. Then about 114. Then it's about 115. Up to 5 bytes then done. Next will be what? 116. So when this data or this packet will be reached here, so now it's this guy will check it. Okay, up to 115 I got it. Now what I'm expecting now? 116. So now I'm sending what? Okay, I'm expecting what? 116. So into this one again, next one 116 it will be start. So then this will be my segment here. How many bytes do we have? 100 bytes. Okay, so then it will be start from 116 up to 215. Got it? So like this way, guys, it will work because the first sequence number will be here 116, then about next is about 117, and it will goes here about 115. And next sequence will be about, sorry, not 115, this is about 215. Okay, last will be 2 and 5, and next sequence number will be 216. So that's why this is mentioned here. Okay, yes, next byte, next segment is next sequence number I'm expecting 216. So like this way, guys, this concept will work.
So this happens irrespective of any protocol under TCP. So
sorry, pardon, please.
This happens irrespective of any protocol.
Any protocol
under the suite.
Any protocol, that doesn't matter. Any type of data.
Okay.
Okay. Because right now TCP is there. Obviously, this is a TCP because UDP we don't have this concept there. Right. So mostly with those protocols like about HTTP, HTTPS, Telnet, SSH, RTP, the applications or on the like on L7 application which is using your TCP protocol for that thing, this concept will be.
Okay.
And UDP, because UDP doesn't support all these things, there is a no, this is sequence number is a random number, Shriraj. Okay, so there's a no specific range and all, nothing is there. That is random number. Okay, so guys, this is your sequence number concept and very important from interview perspective. This, if you can explain in interview, this is good for you. Okay, it will be a plus point for you. Okay, and if otherwise, if you are confused with that, no problem. First, explain this thing, and after that, if you will do this thing, it will be a plus point for you. Okay, for the interview perspective. That's it. So this is about the concept of sequencing number. I'll save it. I have saved it now. I'll save with the sequence number, and then I will upload in the drive. So in case if it will be required, so you can refer this thing. So this is about sequence number of TCP. Okay. After the class, I will upload it. Done. So now with sequence number, we are done here. Okay. Next thing is we will go with the retransmission concept about our timeout and retransmission concepts we will discuss. Okay. Now, let's see what is the retransmission concept and how to start here. Just consider it. Actually, if this is the same topic, guys, it's at the same time we have to discuss all these things because our timeout and retransmission. Let's consider this is one of the server and this is one of the client, and this client has to download one 10 Gbps of file from here. The topic name is timeout retransmission. Well, let me mention here. The topic name is timeout and retransmission. Sequence number, we are done. Now, so in the timeout, so we have to start here and we have the retransmission concept. So into this one, we are going to discuss 2 or 3 things there. The first thing is about retransmission queue. The second is about IRTT. This is about initial round trip time. Initial round trip time. Okay. And RTO, R2 and IRTT, this is the same. Okay. This is a retransmission timeout. Retransmission timeout. After that, SRRT, SRTT actually, this is about smooth round trip. And the next is about time back off. back off. These things we have to discuss. Now, let's start. So first of all, let's see, this is the client 1 and this is client 2. Now, so first of all, three-way handshake process will be done, okay, because about timeouts and all, we are not gonna like sync, or we are not gonna exchange any type of data related with your any type of timeout and all. The timeout retransmission concept will be start when your data will be begin. Data transfer will begin. Before that, we don't have any timeout concept there. I can show you. Let me open the captures. If you will see your sync plus ACK or ACK packet, there is a no concept of like timeout and all. This is source port, destination port. Okay, nothing is there. This is about sync, Windows, calculated checksum, urgent pointer, and option about MSS there. There's nothing related with your timer and all. But when I'm coming with the data, telnet data, this is known as telnet data. And when I'll open it, and you can see here, we have the concept of RTT. This is say initial round time trip here, guys. Okay. Now, what is actually this timer and all? See, when we are sending the packet, see in networking, we are already aware about that. We have some type of keep alive message and all. So these type of things we have. Let's consider now I'm sending I'm a client, okay, and I'm sending some data to the another PC, or I'm a server, maybe anything. I'm sending the one segment here. This is my data with sequence number, consider 1. Okay. Now into this one, my byte is about 10. So my next sequence number I'm expecting here 11. This is. So now I just sent this particular packet here, and now I'm waiting. I'm waiting for what? For acknowledgement. Now I'm waiting for what? I'm waiting for acknowledgement. So when I'm sending this data here, let's consider I have sent this data, okay, and after that I received acknowledgement, okay, and acknowledgement as a what? 11. Just consider for this one, when I have exchanged this particular segment plus acknowledgement, I received the acknowledgement here. Let's consider this acknowledgement I just received within the 20 milliseconds. Milliseconds, or could be microsecond, anything. Okay, this is about the 20 ms. Okay, let's consider this can be possible. This is the, let's consider this is the directly connected device, or maybe it can be possible here. You consider this is the PC1, PC2, and in between that these are the some routers there. Just consider it, and this is connected like this way there, and this is also connected this way. Right now, how many paths from this router, guys? Tell me how many paths do we have to reach this particular client? Means from one PC1 to PC2, we have 2 paths. Maybe this can be possible. My segment 1 is going through this one, and segment 2 is going through this one here. Maybe some load balancing is there. Maybe this path may be down in the second time. I have backup path. So many things, so many reasons are there. Okay, so this is about 2 paths there. So this, it can be possible when I'm sending from here, so it's taking what? 20 ms. And when I'm sending my second packet, it will be about what? This is, it will take your 30 ms or maybe 50 ms. Consider it. This is a little bit late. So this is when now we are getting this time of 20 and 50. This time period is all known as RTO. Okay. This is known as RTO, retransmission, not RTO. This is known as IRTT actually. Initial round trip time. Initial round trip time. Key initially how much time it took actually. When they exchange these first 2 segments, okay, after that your client will decide one specific timer for that. Okay, okay, 21st when I send my segment, that was 20 seconds. Now I'm sending my second packet, it took 50 seconds. So there is one nasty formula there. There's a one nasty formula is there, and that nasty formula will decide. And what it will decide? It will decide कि 20 plus 50, it will decide one specific or one timer. Okay, that is, let's consider कि okay 35 seconds. 35 seconds कि okay कि overall your RTO retransmission timeout is about 35 seconds. Or this is also known as smooth round trip time, SRTT. So it means next time when you will send the 35 segment number third, okay, so now my SRTT is what? That is 35 ms. So now I have to wait for 35 ms. And if within 35 ms, if I'm not getting any acknowledgement, I will retransmit the same segment again. Retransmit the segment again. Okay, retransmit. Okay, so now after how much time? After 35 ms. So this is this concept is known as about your RTO retransmission timeout. Your retransmission timeout is over now, and now please start it over there. Okay, or you can say what is your retransmission timeout? That is about 35 ms, and this is also known as SRTT, your smooth round trip time. Initially, that was IRTT, initial round trip time. Ki initial, what was there? 20 plus 50. And now what they decided? 35 RTO. That is about retransmission time, or this is also known as SRTT. They will use one nasty formula, and behalf of that, they will do it. So let's consider, take an example. This is first segment, 20 ms, reply got back. Second one, 50 ms, and now reply received. Now in the third one, what we are deciding here, we are deciding ki, okay, now RTO timer is what? That is about 35 seconds, or this is also known as SRTT. So when we are doing this thing, I'm getting the reply. Just consider this reply I received within the 30 ms or maybe whatever, but still my RTT is what? 35 only. Let's consider I'm sending the segment number 4 and I'm not receiving any type of acknowledgement within this timer, because this is my SRTT. Okay, this is about RTT here. So what it will do now, it will retransmit the same segment. This is what? Retransmit. So once it will retransmit it, the same segment number 4, this time it will increase or it will double its SRTT timer. Ki, okay, within 35 ms I'm not getting, so it means some congestion could be there in the network. So obviously if I'm not receiving right now within the 35 ms, so obviously I can't expect ki, if I'm sending this next, if I'm doing the retransmission and in the last time I didn't receive any acknowledgement within the 35 ms, so obviously I can't expect with this packet also. So what I will do this time, this timer I'll make it double now. So from 35 immediately directly double, it will be double directly. I'll make it 35, 70 now. 35 into 2. So this new timer, when we are doing this concept, when this is a new SRTT this time, so when we are doubling or when we are increasing the timer, this concept is known as back off timer. Timer back off. This is timer back off. Okay, let's consider again, if it will be not we are not receiving within this timer also, again it will be increased, it will be make it 140. So this is again timer back off. Next time again 280 here, then 5, 8, 8, 6, 80, 80, 40, 60, 560 there. So now like this way it will increase the timer. Okay, so every operating system has one timer, particular time period. Let's consider I'm using a Microsoft here, and Microsoft decided ki max to max now you can go with the 1000 ms back your timer back off. Once your this timer will cross this concept, and still if I'm not receiving any acknowledgement, then your TCP connection will be disconnected. now we are not getting any reply. I'm sending continuously data and that guy not sending any acknowledgement. So now I'm not sending anything. Sorry for that. And now we are going to terminate this connection. So then who will terminate the connection? This guy will terminate the connection. Okay, so for that connection again, it will try to send the fin and all. So again, we will not get any reply. So that concept is about forcefully terminate the connection. This is the concept of your timeout and retransmission. So this is about IRTT, initial round trip, time trip over there, 20 plus 50 second ms over there. Then from here, they will decide what is RTO and SRT, that is about 35 seconds. If within 35 ms we are not getting any reply, so we have to go with the concept of time backup, means we have to increase it. We have to make it 70. So then this concept will come in the role. So this is the concept of timeout concept. And these are the IRTT, RTO, SRT, and then time backup there. From interview perspective, this is also important. This concept is there and this concept is there. RTO, no one is using, but some if asking you RTO, so this is the concept of the same SR. Yes, guys. Any questions? Any doubt? Yes, guys. Any questions? Any doubt? Retransmission is pending. The same sequence number will remain for that, Anjana. And now once I'll finish queue as well, then it will be clear. Okay. Now I'm coming on the retransmission queue. Now the thing is, okay, when we are doing what is the retransmission queue, guys, as a server, let's consider I'm a server. Okay, this is one of the server, and this is the client, and it's trying to download one file. It's downloading one file of the 10 GB. And now I'm sending the data in the segments here. So let's consider this is the first segment number 1, segment number 2, segment number 3. In every segment, just consider I'm sending the data about 1400 bytes. Just consider it 1400 bytes, 1400 bytes, 1400 bytes. Consider the sequence number of this packet is 1. Okay, this is about 14 and 01. Okay, and this is about 280. No, this will be very big data. Okay, I'll make it easy. 1 second. Hundred bytes of data. Consider it. I'm sending 100 byte. I'm sending 100 byte. I'm sending 100 byte. Sequence number start with 1. This is about 101, and this is about 201. Okay, these are the sequence. This is the sequence number here, guys. As a server, I'm sending this data to the client side. Client has to be acknowledged all these data there. So on that time, when I'm sending the data side by side, your server will maintain one retransmission queue. Retransmission queue. Okay, what does it mean actually? Retransmission queue. See, when we are sending retransmission queue means when I'm sending this is segment number 1, segment 2, segment 3. At 3 timer, I'm deciding 3 timer, guys. Time T0, time T1, time T2. Okay. Time T0, at time T0, I'm sending segment 1. Then time 2, I'm sending segment 2, and this one I'm sending segment 3 here. And side by side, it will maintain the data about segment 1 and segment 2 also. Okay, time T0 only segment 1 send. If I'm coming with the time T1 and just consider it up to now there is a no acknowledgement, nothing I have received. So now this is about S1. This is about now up to now no acknowledgement, nothing is there. At time T2, S1, S2. How many segments I have sent? 3. Now at time T4, because my window size, according to my window size, I can send 10 segments at the same time without any acknowledgement. Okay. 1 second, guys. Now, when I'm sending the 4th segment here, okay, just consider before the 4th segment, I received the seek acknowledgement for this one here. Okay, for the first segment, this is the segment 1 acknowledgement. So now consider I have to send segment 4, and before that I received this one here. So now what I will mention here, now this one, this is my retransmission queue. It's in a data, actually type of data. S4 I'm sending, S3 no acknowledgement up to now, S2 is nothing, S1 was there, but now I have received S1 acknowledgement. So let me remove it from here. So because I received the acknowledgement of this one, so that is not required here. When you will receive the segment 2, okay, when I'll receive the segment 2 here, so on that time guys, I'll remove from here S2. When I'll receive segment 3, okay, acknowledgement, I'll remove segment 3 from here. And when I'll receive about segment 4 also, I will remove it from here. Okay, now I'll receive segment 4. So I received all the acknowledgement for each and every packet. So on that time, there's a nothing. So means if nothing is there in my retransmission queue, so it means I have received, okay, all the acknowledgement concept. So this concept is known as about your acknowledgement concept. And in case if we have to retransmit some data, so on that time the sequence number will remain same. Okay, let's consider, let's take an example. Segment number 1 and my sequence number 10. Just consider it. Segment number 2, sequence number 20, segment number 3, segment this is over here. I'm sending first one. This is my retransmission queue. One second. This is my retransmission queue. So in the retransmission queue I'm using here. Now, first of all, I'm sending which data? I'm sending segment number 1. Okay, it's go. Now, when I'm sending this one, segment 1, so side by side, it will maintain, not in the retransmission queue, but it will maintain your sequence number also. Okay, sequence number is 10. Now I'm sending sequence segment number 2 with sequence number is 20, and S1 I have already sent, which is about 10 here. Next time I will send segment number 3, okay, and segment number 2 and segment number 1, and this is about 10, 20, and 30. Let's consider if I have to transmit some time, okay, that is in the next topic is about this one only. If we have to send this, let's consider S2. S1 acknowledgement I got it, and I have now removed it because acknowledgement I received it, now not required. And just somehow just consider it now S2 you have to send it again. So when I have to send the segment 2 again, so the same sequence number I have to use, because the next segment, maybe just consider that this segment is already reached there. So on that time, this guy has 30 and 10, but this guy is missing what? 11 to 20 here. So, and who likes containing this 11 to 20 concept? Segment number 2 here. So here the segment concept I have to go with the 20. Got it? So means during the retransmission, the sequence number will remain same. The same means the same sequence number which we sent last time. Okay, so they are not gonna change any type of your sequence number concept. Okay, so within this concept only, we have one more concept there that is known as S-ACK. S-ACK means that is about selective acknowledgement. Selective acknowledgement. What this selective acknowledgement does means, see, actually see, this is very important. Listen, okay, see it carefully. And this is the client and this is the server. And this is the first time I'm sending in a request, please send me some data, or I'm just trying to download some file from that. So now how it will work there. This server received a request, okay, I have to send the data now. What I'm doing, I'm sending segment number 1. This is what? This is acknowledgement request. This is the data request for the data. So this is what? Acknowledge request, and now I'm sending what? Segment number 1. So this is, guys, my segment 1. Acknowledge plus segment number 1. Two things I'm sending at the same time. I'm sending segment number 2. I'm sending segment number 3 also. Okay. Side by side, this is my retransmission queue, and it's maintaining here. See, acknowledgement when we are sending the first segment, segment number 1. I am sending segment number 2, segment number 1, segment number 2. Third time, send the acknowledgement number 3, and segment number 1, segment number 2, segment number 3. Because up to here, I haven't received any type of acknowledgement from the client side. After that, what happened? Just when I'm sending these 3 segments at the same time, in between or somewhere, my segment number 2 lost somewhere. Got it? This is lost somewhere, okay? Maybe because of some congestion, maybe some of network issues and all. And segment number 3 reached there. Segment number 3, what? This is reached here. If I'm talking about segment number 1, which we sent, it's reached there, and now it's sending what? Acknowledgement. So we are getting the acknowledgement for the segment number 1. So when I receive the acknowledgement of the segment number 1, I'll remove it from where? From here. Got it? This is what? This is about the segment 1. Okay. See, up to here, is that clear or not? I'm talking about this queue here. Up to here, that is clear or not? Read this one. Because we received the acknowledgement, and now segment 2, segment 3 is pending, but server is not aware about that. Segment 2 is lost somewhere. According to him, I have sent segment 1, segment 2, segment 3, but I have received acknowledgement of what? Only segment number 1. This is clear? Okay. This is important concept here now. You see segment 1, that is okay, but segment 2 and segment 3, there is a no acknowledgement for that. Okay. Next is what? This guy is receiving what? This guy received segment number 1, and just consider the segment 1 acknowledged sequence number 10, and after that this guy have received segment number 30 also, 3 also, and this sequence number is about 30 here. So client is also maintaining what it's maintaining. It's maintaining its sequence number. Okay, I have received sequence number 10, and now I have received 30. But in between that, something is missing here. Got it or not? Something is missing, because in between 10 I have received and 30, because I have acknowledged last time, I am expecting now your 11. Sequence number next is about, consider, I am expecting 20, 9 bytes data was there. So, but what I'm getting actually 30, but what I was expecting 20. So where is 20? That I don't have any. So after that, it means I have to inform to the server that I need packet number, like segment number, the segment which has the sequence number 20 there. So immediately I will send one more acknowledgement here, and which is this acknowledgement, the same acknowledgement which I have sent before that. Duplicate acknowledgement of the second segment 1. This is the main important thing here, guys. What I'm doing, I'm sending the same acknowledgement. See, last time I have sent what? I'm coming back here. Let's check. Now see, this is that server. This is that server and client. Okay. Now, segment number 1, segment number 2 lost somewhere, and segment number 3. Okay. Let's consider in the first one, I'm sending the sequence number 10, and next sequence number I'm sending about 10 bytes data, 10 plus 10, 20 here. Okay. Into this one, I'm sending now next sequence number 20, obviously, because I have mentioned here. And now next sequence number again about 30. And this is I'm sending about sequence number 30, and next sequence number is about 40. Clear? This guy is receiving all these packets. Now this guy, what is doing? What this guy is saying, okay, I'm expecting what? I'm receiving this packet number 1, I have to send acknowledgement. I'm sending the acknowledgement, and acknowledgement number what I'm sending? The sequence number is what, 10, and the what is the and next sequence number is what, 20. So what is my acknowledgement number? That will be 20 only, because the segment length is what, 10. Same here, segment length is 10 and segment length is 10 here. So 10 plus 10 is what? Next I'm expecting what? 20. Is that clear or not here, guys? Guys, is that clear? Clear now? Okay. Now this is okay, but I'm expecting now. Now as a client, I'm waiting for what? I'm waiting for the next sequence number as a what? I'm waiting for the 20 because I have sent the acknowledgement as a 20. But somewhere in the network, this packet got like about or lost somewhere. So what is happening now? Right now, in the next one, it's sending the sequence number 30 here. And now I'm receiving the packet number with sequence number of what? 30. And now guys, I'm confused because last time the sequence number was 10 and now I'm getting 30 and I was waiting for what? I was waiting for the 20. So the question is, where is 20? Clear? So then I'm doing one thing, okay, let me request to the server. Okay, even server will also send it after the RTO when the retransmission timeout will be expired, and obviously I'm not sending any acknowledgement, so server will send it to me again. But before that only I'm sending a duplicate message. Okay, I'm not waiting for that timeout. I'm sending the message to this guy, to the server. And what is this message? Actually, this message is like, please resend me packet number, segment number 2. But exactly what is this one? This is the same acknowledgement. Okay, I'll mention here acknowledgement 20. I'm expecting 20. And this is what? This is duplicate acknowledgement. Now on the server side, we have already received last time, because last time when I have received the first one, so I have already removed that entry. So now server will think about that, why I'm getting duplicate acknowledgement. So it means if I'm getting duplicate acknowledgement in the network, so it means packet lost is there somewhere. Some packet drop is there, means segment lost is there in the network. Congestion is there somewhere. So means my another side, that guy is not getting all the packets. So that guy is sending what? Duplicate acknowledgement. Please, duplicate acknowledgement is this type of please retransmit the packet. So what this guy, what now server will do? Server is receiving acknowledgement what? 20. So it will check it, okay, where is my acknowledgement? This is 20. What is the 20? I'm expecting next sequence number 20. Then this server will check it, where's my sequence number 20? Okay, this is on segment number 2. So what the server will do? Server will retransmit segment 2 with sequence number 20, and it will retransmit segment 3 also. Yes, it has to send actually segment number 2 only, but it will send your segment number 3 also. And into this one, it will mention the sequence number will be 30. So now just consider on the client side, actually 10 and 30 I had already. The segment number 1 I had and segment number 3 I had. I was expecting only segment 2, but what is the server is doing? After the sequence number 20, if 100 segments are there, it will send all the 100 segments. Right now, see, I'm using segment number 1, segment 1, segment 2, segment 3 I'm using. Just consider it, if we have 100 segments here, and this is the single window, and your server is sending without any, because what is the meaning of window? Window means server can send, or any PC can send. Let's consider my window is what? 100. So it means according to server, according to window, I can send 100 segments without any acknowledgement at the same time. This is actually Windows actually. Okay. So according to Windows, just consider I have sent 100 segment already. And now I'm getting the duplicate acknowledgement of packet number 1 itself. So it means this is possible here. This guy sent segment 1, segment 2, 100 segment already sent. This guy received segment 1, segment 2 missing, segment 3, segment 4, and now up to 100 all the segments received here. This is also received. What is missing? Segment 2 only. So actually I need segment 2 only, but what I'm doing actually when I'm sending the duplicate acknowledgement of segment 1, because segment 3, segment 4 acknowledgement I can't send. I have to send it always before that, not after that. Before segment 2, which segment was there? Segment 1, and I'm sending duplicate acknowledgement for the segment 1. So what this server will do, this server will check it. Okay, I'm getting this duplicate acknowledgement of segment 1. So it means after that there is a no packet, means no packet read, no segment reached at the server side. So automatically this server, what it will do, this is about segment 1. Okay, it will send segment 2 to 100 segments again. Actually, are you getting this point or not? Yes, is that clear or not? Good morning, guys. Are you clear? Okay, I'm repeating it again. See, I'm not adding sequence number concept here, just I'm using segment keyword. Will be easy for you to understand. The segment, oh, not this one. Sorry. 1 second. Segment 1, segment, then segment 2, segment 3, and up to 100 segments sent. Segment number 100 here. Got it? This guy, consider this guy received segment number 1, segment number 3, 4, 5, 6, and up to 100 here. Okay, and this guy is sending what? Acknowledgement ki yes, I received segment number 1. Okay, so before going to the next packet, this guy, what it will do ki, okay, next one is what? This is a segment number 3, this is a segment number 1, where is segment number 2? So immediately it will send, this is about what? This is acknowledgement. This acknowledgement, this guy will send it again. And this acknowledgement is known as duplicate acknowledgement. This is about duplicate acknowledgement. So the duplicate acknowledgement is what, about which segment? Segment 1. So then this guy will think, I already received acknowledgement for the segment 1. So why that guy is sending it again? So it means if that guy is sending again the segment number 1, so it means ki after segment number 1, that guy haven't received anything. This is I'm thinking, because I'm thinking that that guy received only segment number 1. Okay, because I'm getting duplicate about the segment number 1. After that, nothing is there. So this guy, what this server will do, if I'm receiving the duplicate acknowledgement of segment number 1, so after that, if 1000 segments are there or maybe 99 segments are there, all the segments I'll send it again actually. So it will segment number 2, segment 3, 4, 5, 6, 7, and up to 99, or means up to 100 there. Total will be 99. Clear? So it will be retransmit all the segments again. So guys, tell me, is that an advantage or disadvantage? Obviously, this is a type of disadvantage. Duplicate acknowledgement is good. Duplicate acknowledgement is okay. Ki I'm just trying to inform ki okay, no, I'm not getting this thing here. Okay, I'm not, and I haven't received any segment number 2. Okay, that is just type of duplicate acknowledgement. But on the server side, one issue is there ki that server is doing ki after second acknowledgement, after first segment, it's sending all the segments again. So I have already all these segments, 3 to 100 I have. Why that guy is sending? I'm not understanding that thing. So for that thing, we have a solution. The solution is known as selective acknowledgement. SAC as the solution. What is a selective acknowledgement? Nothing is there. This is very common sense. In this selective acknowledgement, it will mention कि I need only segment 2. See this PPT, this diagram, without selective acknowledgement. This is a retransmission, but without selective acknowledgement. It's sending a duplicate segment here. Okay. Immediately, this is the duplicate acknowledgement for the segment number 1. So total 3 segments we are using. After that, it will this. So what are the 8th step? It will send both the segments again. Segment 2 and segment 3. But segment 3 so is already there now. Why you are sending it again? That is not required. So then we have to come with a one concept there, and that concept is known as selective acknowledgement. With selective acknowledgement, TCP selective acknowledgement. So what actually it will do, up to here the same concept. Fact segment number 2 lost somewhere. Okay, segment number 3 this is placed here. At the place of the duplicate acknowledgement, I'm repeating it again, please listen it carefully. After the first acknowledgement, okay, now as just sent what? See here, this is what? For acknowledgement for the segment 1, and this is removed from here. The 6th is what? This is now we are sending selective acknowledgement. This is what? This is a part of the options only. SAC. I also have byte from the segment 3. I have received, and what is this message? This is a duplicate. Actually, this is the selective acknowledgement. Okay, this is not the duplicate acknowledgement. This is the selective acknowledgement. In the selective acknowledgement, what we have to mention key one I have one. Actually, it's already aware about the one it has. I have 3 to all the 100 pass segments there. Please retransmit me exact segment number 2 only. Don't send me the remaining segment because those segments I have and that is not required. Clear? So according to this option, segment 1, segment 2 and segment 3. So this is segment 1, segment 2, segment 3 was there. Immediately we received one acknowledgement, it's removed from there. Now segment 2, segment 3 is there. I'm sending a SAC here, and a SAC I'm saying I have segment 3 already. Don't send me segment 3. So this is what type of acknowledgement. So it will remove it from there. Okay, segment 3 is also reached. No need to send it. And now about segment 2. So now let me send just about retransmit segment 2 on. Clear? So this is the concept of retransmission. This is request from the downloading side. If you are trying to download some file and if your PC is sending some request, so that concept is about your retransmission. Wins selective acknowledgement. Don't send the duplicate. It's happened in some time in TCP, and if we are doing some practical and all. So sometime it's happened we are getting duplicate like about TCPs over there. So on that time, duplicate acknowledgement. Okay. So that is this concept here. So right now, guys, we don't have any duplicate acknowledgement concept, which is a better option for that. The selective acknowledgement. This is nothing in a single line. If you have to finish your selective acknowledgement definition, this is nothing. It's just I'm requesting for a particular segment. If you have to request to the server for the particular or for the selective segment, so on that time you have to use selective acknowledgement. I need out of 100 segments, I need segment number 10. I need segment number 20. I need segment number 40. I need segment number 75. So on that time, you have to use selective acknowledgement. Because if you will send duplicate acknowledgement at the place, let's consider your requirement is that my requirement is I need segment out of 100. I need only segment number 75. And if you are sending duplicate acknowledgement at that time, so what your server will do, from now I'm a server now. As a server, if I'm receiving the packet or segment number 75 duplicate means duplicate acknowledgement of the segment number 74 because 75 is missing. So what I will do then from 74 to the 100, all those segments I'll send it to you again. Means I'll retransmit again there. But actually my requirement was only packet, now only the packet number, only segment number 75. Okay. But somehow what I'm doing, I'm sending it all the segments actually. Got it? So this is the concept here. Is that clear, guys? What is selective acknowledgement? What is the disadvantage without without SI, and what is the advantage of SI? Interview perspective, 110% they will ask you these questions. Okay, don't try to do this thing. Okay, this is little confusion and all. So I'll keep it like this way. MS windowing. Okay, in the window skill, which we have discussed yesterday. Okay, then about MSS. Okay, then about SAC. These are the very, very important concepts. Actually, both are these part of the options actually. You remember now in the TCP header in the bottom we have one field, and that is field is about options. Okay, we have so many options actually, but out of almost we have 7 to 8 different options. But out of all the 7 to 8 options, MSS and SAC is the important option, guys. Okay, so don't like keep like this thing, okay, we will do it later and all. Okay, because this is very, very, very important concept. Even in the G scalar and all, these are G scalar. If you remember the if you know G scalar, there is a company. So these companies and all over, it's always their first round about TCP there, and always they're asking these type of questions. What is the MSS? What is the SAC? What is the three-way handshake? What is the four-way handshake? Okay, they can ask you, okay, explain SAC properly there. So then you have to explain all these options. Always try to practice with sequence number. Okay, because sequence number plays very, very important role into that. Okay, so try to make it like in a sequence. Okay, first I have to do the sequence number. Before that, obviously three-way handshake process and all, whatever we have discussed, that is important. Sequence number, acknowledgement number, what is the random number. Then after that, windowing is also important, very, very important. What is the MSS here? Okay, during MSS, all the MTU size and everything you have to go through that. Okay, and after that, this is about your SAC. This is also very important. Then RTO, what is SRTT? Okay, and what is your timer back off? What is the retransmission queue? That is also important. Okay. So guys, if you have any doubt, if you have any question up to now, so guys, you can ask me. Done. Please refer your RFC number 793. This is the RFC for your TCP. Please refer this RFC. This is a good RFC for that, and try to go through it. And otherwise, book is also sufficient. If you want to go through the RFC, please go through the 793. So guys, up to now, we have discussed this thing we have done, completed this thing. Okay, we have completed with the TCP socket segment windows, active opener, passive openers, explain the ISN. Okay, identity sequence number we have done. We are done with the blocking structures, handshake we are done. TCP half close is pending. Okay, because still we haven't discussed about the FIN packet. FIN we have to discuss there. Then TCP segment creation, what is the biggest segment I can create? We have discussed yesterday. One about the streams into segment discussed yesterday. Sandcall, Nagel, Elko, what is go on? Largest segment we have discussed. MSS we have discussed. Windows concept we have discussed, scaling concept we have discussed. Today we have discussed about retransmission, TCP session timeouts. It include the following thing: RTO, SRTT, timer backup, SI, selective acknowledgement. We have discussed it. The next class, tomorrow, okay, we will start with reset segment, okay, or maybe we can start with this one. So how many sections are pending? Section 1, 1, 2, and after that 3, 4, and 5, and 6. So 6 sections are still pending. So it means at least 5 more classes. Okay, 5 more sessions. This is the 4th session. So after that, at least 5 sessions more. So this is about, guys, TCP options, which I was just talking right now. So MSS and SAC is very important. These two. Okay. After that, we have so many things about window scale. The window scale we have already discussed yesterday. If you have to increase the size of your window, so then we have to use window scale concept. Okay. So these 3 options we have done. Timestamp, about protection against wrapped sequence number, user timeout, TCP authentication options here. This is also important. So tomorrow we will start, and these are the flags, guys. Sync flag we have discussed, ACK we have discussed. So reset, push, urgent, and congestion mechanism, these we have to discuss here. So in the next class, I'll try to start with the reset over there. Maybe in the reset we have so many states, okay, or otherwise before these states and all, I'll try to cover these things. Okay, so 4 to 5 more classes for this thing. Yes, tomorrow, guys. Okay, next class will be tomorrow only, not on the Monday. Okay. So guys, about today's topic, if you have any questions, if you have any doubts, so you can ask me. Okay. So then, guys, see you tomorrow at the same time. Okay, and 11 o'clock with the new topics. Then we will start. Sure. Okay, guys. Bye bye. Take care. See you tomorrow. Have a nice day, guys. Bye.